So right now during the heat step, this is going to be for the first 30 seconds. The paper wants you to make observations after every step. And I already proposed an hypothesis that the hotter that water gets, the more cornstarch is going to dissolve. So that should be what we're going to observe. That the hotter and hotter it gets, the more and more cornstarch that dissolves and stays dissolved in the water. So coming up on the first 30 seconds now, I hit pause on my phone here. Pop that out. Let's stir it up a little bit. And so after that first step, shot off in the bowl. You showing up pretty good? Mm-hmm. After the first step, the bowl feels pretty warm. The water is pretty warm too. And right now, the stuff is staying dissolved, but I won't be able to tell anything really until after I do this second heat up step, because it'll take a few seconds if it wants to fall out of solution. And just go back to the bottom of the bowl. So here we go. I'm gonna start it. So I'm going for my second 30-second step. So once this is over with, it would have microwaved for a full minute. We're shooting for 1:30. So after this full minute, I'm going to stir it up again, checking to see what's happening. If I see any new observations, I'll write those down. But I'm not expecting to see anything major until after it's heated up for the full 1 minute and 30 seconds. So a minute, that's my second 30 seconds. So now check this out. We have some bubbles. The water's actually pretty hot. So it has a warning on here about the liquid could become superheated. Now, what that means is that actually we have another observation too. So not only has it pretty much dissolved, because if you shine over here real quick, you can see it's real white looking and murky still. That's because most of it hasn't dissolved yet. But here most of it is dissolved, and actually it's forming a kind of a gelatin type of a, you know, oatmeal-y looking substance. If you see that on the spoon, it reminds you of grits, liquor kind of. So it's started to form a gelatin type substance. So remember, after that first 30 seconds, that hadn't happened. So now after the second 30 seconds, everything looks like it's dissolved, because this is clearer than these other solutions, and it's more of a gelatin type of a substance to it. But the danger of the superheating thing is that water boils at, let me get this going. Water boils at 100 degrees Celsius. So if you add stuff to water, it'll elevate the boiling point. So it'll be boiling, but it'll actually be hotter than the 100 degrees Celsius. So not only is it going to burn you, it's going to feel a lot hotter than boiling water would. So you got to be real careful with that superheating kind of thing. So now we're coming up on the 1:30, and we'll see if there's any new observations. But the big thing happened at a minute on this one. So 1:30 seconds. Okay. And it's really bubbling now, so it's kind of, might want to use a hot mitt or something to work this. But yeah, we have pretty much nothing's really changed except it's a lot hotter. You can see those bubbles coming out, and that's really where the hot stuff is at, in those bubbles. That's like vapors trying to escape. Whatever. It's not playing? You need a picture camera for it. It's not showing up good? Mm-hmm. So those bubbles that you see is trapped gas. Well, trapped air. We'll just call it air. And that steam or whatnot, they can get a lot hotter than the liquid itself. So that's kind of why it's like when you open up a popcorn bag, it's real dangerous to watch out for that steam, because it's real hot. It's superheated. So it looks pretty gelatinous, more like a jello, and probably if we let it set, it probably will tighten up and thicken up. So I'll show you what happens on bowl 4, but I'm just going to go ahead and do these other two just to have them.